Hi, welcome to another Level 1 Chance and Data video. In this video, we're going to tackle 4 statistics graphs: the bar graphs, the histograms, the stem and leaf plots, and the pie charts. So let's get started. A bar graph is a statistical graph that displays discrete data. Discrete data is data that is collected by counting. Here's our example. We're going to display the following data in a bar graph. We've counted up the most common pets in 9ZUR. Here is the bar graph. We have a title, our labels, and our bars are equal in width. Now, bar graphs, technically, you can have the bars touching if you really want. You won't get penalised for that. And we can also have bar graphs that are comparative, maybe different years side by side and colour-coded to allow us to compare things as we go. Okay, histograms. Well, these are graphs that look like bar graphs, but they're different. They basically display grouped data. The data used in a histogram is mostly continuous. Continuous data is collected by measuring something. But they can also be discrete data, like the bar graph, and that's data that's collected by counting. Here's the example of our histogram. We're going to display these results in a histogram. They are the heights of students in 9WAN. Now, continuous data is data that's measured. We measure heights. So this one student in this category, there's one student in this category. There are 3 students in this category. So if a student was 150.3 centimetres, they'd fall into this category, which represents students that are 150 and above up to, but less than 155. But if a student was only 149.8 centimetres, they'd go back to this category because these students are from 145 up to, but not including 150. Right, well, this is what the histogram would look like. We have a title, our labels, and again our bars are equal in width. Now, this is the one student that is between 140 centimetres up to, but not including 145. There's one student from 145 centimetres up to, but not including 150. There are 3 students that are 150 centimetres and taller, but not taller than 155, and so on and so on. Right, well, let's talk about a stem and leaf plot. Basically, this is a graph that is used to collect and display data. It's sometimes called a stem and leaf graph. So here's the example we're going to talk about. Mr. Brown and his Year 9 students from a recent algebra test. This is what a stem and leaf plot looks like. Right, we have a stem and we have numbers on the side we often call the leaf. Let's show you. Basically, our stem is our main source, and in this example, it's going to represent our 10s, 20s, 30s, and 40s. So this number here represents 23. The 2 is the 20 and the 3 are the units. Then we have 27, 31, 15, 09 is 9. We have 23, 29, 25, 33, and 28. We put a title. Now, there were no students scoring in the 40s. I don't know why I put that there. And we can clearly see most students scored in the 20s. And sometimes it's useful to order these things. Some people like to take these and put them into order, which helps us with some analysis sometimes. And sometimes it's useful to have a back-to-back stem and leaf plot so we can compare 2 different things quickly. Right, well, our final graph is called the pie charts. Just another way to display data with a circle. The larger the sector, the more items in the category. We can see the favourite takeaways. We can see that the Indian takeaway was voted the favourite from this survey, and that's 35% of the people voted for it, and they have the largest sector in the circle in the pie graph. Now, in case you've forgotten how to do percentages, if you want to work out 13 over 54, go 13 divide 54 times 100, and that gives you your 24%. Right, well, that's us for this video. So thanks so much for tuning in and watching.